I'm thankful to the organizers for this opportunity to give one of the keynote presentations at the fifth Innovative Product Design and Intelligent Manufacturing Systems Conference. I'll be discussing something related to buildings, their indoor conditioning systems, and how future designs will need to incorporate the need for indoor environments to serve as parts of our public health system. Every day, each of us drinks about, let's say, 5 to 6 such bottles of water if we are really careful about our water intake. And if given the choice between this bottle and the other bottle, brownish looking liquid versus a clear looking bottle of water, it's not really a choice, right? Everyone will choose the clean bottle of water. However, when it comes to breathing air, while we insist on drinking clean water, why are we okay with breathing this kind of air? Every day, as I said, we might be breathing in about 5 to 6 such bottles of, drinking about 5 to 6 bottles of water. Every day, we breathe in about 18,000 such bottles of inside air. Every year, about 7 million deaths, premature deaths, are ascribable to air pollution globally. This includes both indoor and outdoor air pollution. And considering we spend about 90% of our life indoors, uh, even the outdoor air pollution, it's going to affect us through our indoors. There are a range of challenges that indoor air faces. So it could be something like a heat wave or a forest fire, or it could be something as innocuous as everyday cooking. It could be due to an epidemic of airborne pathogens, and that could also be volatile indoor air pollutants from building materials, from cleaning materials, and even us, that is the building occupants. Poor indoor air quality, of course, affects our perception of the indoor space, but it goes further. It has a profound effect on our health, well being, work performance, and learning, in addition to just comfort. Let's try to put this in terms of some numbers. 24% of global disease burden is associated with environmental factors, or let's say indoor environmental factors. That's because 90% of our life is spent inside some kind of building or another. And whatever the operational or construction costs of a building, the most valuable resources in a building are its occupants and their performance and well-being, because the ratio of a building's operation cost to the salary of people working inside is about 1 to 40. This is not really a recent realization, as this caption from Business Week about 24 years back points out. Even in 2000, the questions were being asked as to how are our buildings affecting our health and how can we do better? Are our buildings endangering us? Let me just list about 4 reasons why we should care about indoor air quality. One, there are a range of pathogens that are transmitted in stuffy, crowded indoor spaces through the air, including the one that caused the last pandemic. Two, there are a range of non-communicable diseases which are related to indoor air pollutants like particulate matter, volatile organic compounds. They affect multiple organ systems, including our cardiorespiratory systems, brain, skin, and even reproductive system. Poor ventilation is an often overlooked reason for discomfort and poor sleep quality, which in turn goes on to affect your everyday performance and overall health as well. Good indoor air quality is essential for good working environment or good teaching and learning environments as well. Just to reiterate point number two and how pervasive the impact of indoor air quality is on our health, The impact of indoor air pollutants can be virtually found on pretty much all organ systems that you can think of, starting from the tip of your nose to the tip of your toes. So let's look at what some of the studies have shown related to indoor air quality. A study that examined everyday exposure of people to indoor air quality, measuring carbon dioxide levels as a proxy for air quality, found that it depends on the ventilation system being used. Homes using air conditioning had more consistently higher levels of CO2 levels, which implies poor ventilation. And this is particularly during bedtime, that's nighttime. Even opening the windows periodically while you're having the air conditioner operating can dramatically improve your air quality. So it's partly about the conditioning system that you have been used, but it's also partly about the awareness amongst people and occupant behavior. Depending on what kind of home you are in, that can increase or reduce your exposures and thus impacting your experience of the space. Opening doors and windows of bedrooms can have a useful impact on bedroom air quality and consequently improve sleep quality. So this is what we found is that whenever CO2 levels were under 1,000 parts per million, sleep was generally more restful, whereas over 1,000 parts per million, will uh, you are more than likely to have restless sleep. So that implies the impact of ventilation, which we don't necessarily have to just control by windows opening. We could also do with doors or windows opening and improve our sleep quality in bedrooms. Better ventilation and use of low emission building materials has also been associated with improved task performance. Task performance is related to indoor air quality, and it's not just that we need to engage in active energy using measures to design a space with better indoor air quality. There can be passive measures like using lower emission building materials, adhesives, paints, etc., which will improve the indoor air quality and lead to better task performance. The importance of indoor air quality for health is highlighted by not only professional bodies like ASHRAE and RIVA, but also by public health bodies like the CDC and Industrial Hygiene Association. So this is what some of these bodies have said regarding improving ventilation, reducing recirculation of air to lead towards better indoor air quality for health. In general, when we think of the ideas behind dealing with indoor air pollutants, there are a couple of broad ideas or broad measures behind this. One is either we dilute it through bringing in outdoor air, which hopefully is devoid of those pollutants, and the other is we could remove those pollutants using something like filtration. So let's think of it in terms of hierarchy of controls. This hierarchy of control relates to risk management, and it can be extrapolated to the risks from indoor air pollution. And as engineers, of course, we can focus on designing and improving buildings to improve indoor spaces, focused on engineering controls. But at the same time, we can also look at measures related to elimination, like uh, using electricity based heating systems instead of fossil fuel based ones. So that's an example of substitution, or elimination could be eliminating the use of adhesives that emit formaldehyde. So that's also part of the design process. Administrative controls could be related to how you operate your building system. Building energy system or conditioning system, so that you can take advantage of periods when energy is cheaper. So all of these ideas put together uh, means that engineers can contribute quite a bit, including engineering controls, but even beyond, to lead to healthier indoor spaces. Just as a summary, here are a few engineering interventions for healthier indoor air quality. So you can have air cleaning and disinfection within the air conditioning or heating, ventilation, air conditioning systems. You can have UV lamps to uh, kind of kill off some of the pathogens that are found in indoor air. Ventilation is of course there, and it could be mechanical ventilation systems, or it could also be natural ventilations that's encouraged by open windows. You could have a portable air cleaner within the space to kind of capture indoor air pollutants within the space without uh, having the same facility in your uh, HVAC system overall. So there are a bunch of these measures that are already available. Several others are also being experimented upon and being developed further. So whenever you're designing a building, depending on its purpose, depending on what kind of occupants will be there, like whether they will be vulnerable to certain kind of exposures, what kind of exposures are expected based on where the building is located, we can always try to design a space with the appropriate engineering controls and interventions for healthier indoor air quality. This is the basic idea behind how engineering can contribute towards this domain of public health and preventing exposures and improving health. So I had four stories in mind that I wanted to tell that relate to how design innovations have taken place in improving occupant experience of indoor air quality. Uh, to start off, I have the smart air filters in mind. It's a company that started off creating very simple solutions to deal with polluted air in cities of China. Uh, they have progressed over the past decade to become a very established player in producing air cleaning products. They started off with a very simple design, like you strap on a filter to a fan. The fan sucks air through the filter, and in that process cleans the air. From that simple design and kind of a modular design, which was useful at that particular moment, so about 9 to 10 years back, it was useful. They have progressed quite a bit. They have been able to leverage technology well to build some of the uh, really nice filters available today in the market, which are quiet, which perform well, which have good air cleaning performance. Now, this is one of my favorite kind of design interventions that you can think of, because it wasn't started off by some company or some big university. These are called the Corsi Rosenthal boxes, or CR boxes for short. They started off and grew kind of as almost entirely as a grassroots movement, where people were creating this simple design, improving upon it, using quieter fans, using different size of filters to ensure that you can fit it in different situations, hanging them up on the ceilings, using them on walls, sitting them on top of each other to make a compact uh, filter design which can deal with larger volumes of airflow. So it's remarkable how well people have adapted to uh, this kind of intervention or solution once the problem was clearly presented to them. So the presentation was this: that there is stuff in the air which could affect your health, and this stuff could be filtered off with this kind of HVAC filter that you can find in a typical hardware store. And what you can do is you can just suck the air through it using a fan. Great idea. Combine fans and filters, create different sizes, different colors, different uh, uh, performance levels of Corsi Rosenthal boxes. So it's a great kind of innovation and a great movement, and it deserves to be applauded as such. As the well-known adage goes, you cannot control that which you cannot measure. Measuring carbon dioxide levels indoors is frequently used as a proxy for indoor air quality and ventilation. It's because it's generally easy enough to measure. The sensor used is not very costly, and we have a nearly consistent reference for outdoor CO2 levels, which is kind of uniform globally, though there might be small variations. So the Aranet monitors, they came into market with the capacity to measure temperature, humidity, and CO2. providing a reasonable picture of the indoor climate. Their entry kind of coincided with the pandemic and increased awareness among people about indoor air quality, and this helped them to establish themselves. That said, they do make a pretty good product with good firmware updates and consistent performance, ease of use. It has got a great battery life and reliable readings, which has helped them to become very widely used and kind of capture quite a bit of this niche market. The origami masks release also kind of coincided with the pandemic. It was an interesting design innovation for masks, and its design made it suitable for a wide range of faces, different sizes, different shapes of faces, and it was also easy to store when not in use. That implies easier reuse. Unfortunately, the pandemic also gave rise to this kind of extreme views on masking, and they could not continue the productions. They had to unfortunately shut down. So, there are this range of solutions that we as engineers could propose for healthier buildings, and we could also innovate. Depends a bit on what kind of products you have in mind, what kind of innovation you're proposing, and also your timing. But overall, let me put it this way. Water sanitation is one of the earliest examples of the interdependence between public health and engineering. As we have come to expect clean drinking water as a part of our everyday life, we propose that we move towards measures of indoor air sanitation so that clean air also becomes a part of our life that we come to accept and expect. Uh, to this end, as engineers, we can design and innovate product systems, even controls that can be part of our buildings or even part of a microenvironment around a person. And since unlike say like cars coming out of a factory, they're pretty much all the same. On the other hand, every building is a little different from the others. There are ample opportunities thus available to innovate. So what's next? There are some challenges for us as researchers and engineers, which could be related to equity of the solutions that we provide and combining energy efficiency and comfort with the requirements of health. There are some challenges for the public as well. As a part of the public, uh, we should be aware and informed occupants, and we should be uncompromising when it comes to health. Thank you very much, and thank you for this opportunity once again.